Hi, everyone, and welcome back. It's Kira Garfulo, Greenville Tech Math 155. Today, we're going to talk about section 3.3, which covers applications of percent of difference. So remember in the last section, we talked about percent difference, and this section is all about using what we just learned, okay? So remember that we talked about the percent change being the difference in prices, if we're talking about prices, divided by that reference price. That's going to give you a decimal, and you multiply it by 100% to convert it into that percent, okay? So you're going to be you need to know what your reference is. That's going to be important, and you're looking for the difference divided by that reference. So let's start with a practice problem. Let's say that the budget revenue of your company was $42,500 and the actual revenue was $54,300. What is the percent of the difference? Well, here we need to think about what is our reference, okay? And it doesn't blatantly tell us the reference. But if we think about this in practical terms, you're not going to know what the actual is until after it happens, right? So your point of reference is what you planned on. What did you plan on? Well, we budgeted for that 42.5. So we're going to make this be our reference, okay? So remember that we are going to take our 54,300 and subtract our 42,500 from the budget. And then we are going to use that budget as our reference. Now, if we plug this into our calculator carefully and convert it into a percent, we'll see that that is going to be 27.8%. Be sure that you can calculate this on your own. Now, a lot of people like these next few slides, right? And a lot of this section covers on discounts and markdowns and sale prices. So everybody has their eye on something, right? And then one day you open an ad and it's on sale for 25% off. Well, what's that going to actually cost you? That's what we're going to talk about now. So a markdown or a discount occurs when that price is lowered. Remember, as a consumer, we usually see these as sales. Sometimes you'll see, oh, it's $10 off. That's not what we're talking about for today. We're talking about when it's 25% off or 10% off or whatever percent off. We're going to be decreasing that cost by a certain percent. And to calculate that, we're going to look at this formula. It's the same formula you've already seen. What's the difference in the price on the numerator divided by the previous price? And then write that decimal as a percent. Okay, so if you need to, remember just as times 100%. The previous price is going to be our reference, and that's because you're comparing it to what it was. That is your reference of comparison. Let's consider an example. A pair of shoes that you like usually sells for $120. This week you see an ad and they're on sale for $90. What's the percent of the discount? Well, this is going to be our reference, okay, and this is our new price. So we're going to look at the difference in the two and divide it by the reference. So the difference in the two is $30 divided by that reference of $120, and that gives us 25%. So our shoes were 25% off this week. Now keep in mind that our reference value for sales and discounts is always the original selling price, okay? Just like up here with $120. You're wanting to talk about what percent it is off from what it is listed at, okay? Now, typically, from the business standpoint, we're going to be looking at it a little bit differently. Businesses make their money if they're selling items, right? They're going to mark them up. Typically, they're going to increase it by a set percent, and it's going to be called the markup or the margin on the item. Everybody's heard about the term profit margin, and that's really what we're getting at here. And there are two ways that we can calculate the markup. They are going to give you different answers. So be careful here, okay? Make sure that you know what your reference value is. One of the ways uses the cost as the reference, and the other way uses the selling price as the reference. Both of them are valid, okay? So if you find yourself in this position, in our class, it's going to tell you which one is your reference point, okay? But if you're using this in a business setting, make sure that you clarify what you're using as your reference, because otherwise you might be on different pages with your management, different pages with accounting, you know, things can get nasty pretty fast. So This is just an application of everything we've already done. It's that percent change. Our markup is our selling price minus our costs. So that's always going to be our numerator, no matter which way we do it, okay? We're going to be taking the markup divided by our reference and write it as a percent. So if we're basing it on cost, then cost is our reference. And we're basing it on selling price, then selling price is our reference, okay? It's going to, when you see based on, that is going to be your reference, okay? Let's consider some examples here. Let's say $50 for the business to purchase, and then they sell it for $70. Pause for a moment and try to calculate the percent markup based on cost and based on selling price. If you need to pause, that's a good idea. If we're going to do it based on cost, we need to look at that difference between the $50 and $70, and then we need to divide it by the amount of cost because that's our reference. So you're going to get 20 divided by 50, which is going to be a 40% markup. If you're going to calculate it based on selling price, your numerator is going to be the same. Your numerator will always be that markup, okay, that selling price minus cost. But your denominator here is going to be 70 because now it's based on the selling price. So this is now 28.6% roughly. Generally speaking, the percent markup based on cost is going to be higher because generally a business cost is lower, and when we divide by a lower number, we get a bigger number as our answer, okay? The only time that wouldn't be true is if you're selling it at a loss, which some businesses do. There was an article floating around a while back about how Walmart sells Pop-Tarts at a loss, for example. That's not always a bad business strategy because they get you to walk in the door. Most people don't go in and buy Pop-Tarts and leave. They buy other stuff. And that's a big business strategy to get you in the door and make money elsewhere. Okay, take a moment and pause and give this one some practice. You have an item that costs $30 and you sell it for $35. What's the amount of your markup? So what's that numerator dollar amount? And then I want you to find the percent markup using cost as the reference and using selling price as the reference. Okay, so if we want to do this, the amount of the markup is just the difference in the selling price minus the cost. So it's just going to be $5. Now, if we're using cost as our reference, then our percent is going to be that 35 minus 30 divided by our cost of 30. So that's our denominator. If we calculate this, it's going to be 16.7%. If we use our selling price, my handwriting isn't even legible for me. We're going to have the same numerator, but now instead of using the cost, we're going to use the selling price. So if we calculate this, we get to be 14.3%. As I said before, remember that it makes sense. The cost percent is going to be higher. Let's give it one more practice. If a TV costs $200 for a store to buy $500, what's the percent of markup based both ways? So we can calculate based on cost and we can calculate price. Based on cost, we're going to see that's 500 minus 200 divided by that cost of 200, which is actually going to give us 150%. Now, when you see that, you might say, wait, that can't be true, but it is. They only paid $200 for it and they're selling it for $500. So they are more than doubling, right? Well, the 150% increase means that it is 150% more than 200. So 150% of 200 is going to be 300, and we're going to add that to the cost. So that makes sense. A huge markup, right? Selling price, we're going to see 500 minus 200 on our numerator still, but now we're going to use that 500 as our denominator, and that's going to give us 60%. Still a pretty solid markup. Now, let's say that we want to relate our original price to the sale price. okay? There are two equivalent formulas that we can use. The sale price is going to be that original price minus your discount amount. This is in dollars, okay? Or you can have sale price equals the original price minus percent discount as a decimal times the original price. These are equivalent because this gives you that discount amount in dollars, okay? If you know the discount amount, simply subtract it. But if you only know the percent of discount, then you're going to need to go the latter approach. That's going to be a little more common. So for example, an accent chair was originally marked at $450, but it's 20% off this week. What is the sale price? Well, the original is at $450, and our discount amount is 20%. Okay, we don't know the dollar amount, so we need to find that. 20% of $450 is your discount amount. Okay, or this is 20% of $450. So we're gonna have $450 minus 90, which is gonna give us $360. So you can go buy the chair for $360 today. Now sometimes we want to work backwards though. Let's say that you bought a love seat and you paid $360, which was 40% off of the original price. What was the original price? How good of a deal did you get? Well, we need to work backwards. We're going to use the same exact equation, okay? We're going to still have that sale price equals the original minus the discount amount, but our discount amount is still going to be original. This is the percent of the decimal, and X is our original. We're going to let X equal our original because that's what we're looking for, okay? We're going to let that be X. If we write this here, algebraically, we're going to get 360 equals X minus 0.4X. In words, that's 360 equals whatever the original price is minus 40% of the original. Remember the X minus 0.4X is going to give us 0.6X. Remember that's the same as saying 1X minus 0.4X, which if we want to factor out the X, we get X. So this is how it's going to end up like this, if you don't remember how to do that. And so we're going to end up with 360 equals 0.60X. Solving for X by dividing by that 0.6. We're going to see that 600 equals X. So the original price of the love seat was 600 and you paid 360, which was a pretty good deal. Okay, take a moment and pause. I want you to solve these two practice problems. The price of a chair decreases by 15%. If the original price was 500, what's the price after the reduction? This is fancy for saying, what's our sale price? Okay, so we know that the sale price is going to be the original, so that $500 minus 15% of the original, which if we do that in our calculator, we see that it's going to be $425. So today you can go buy that chair for $425 instead of the original of 15 or of 500, excuse me. It's 15% off. Okay, an item was originally marked 300. If it's later advertised at 10% off the original price, what's the sale price? Same thing here. We know the original. So our sale price is going to be 300 minus the 10% off of that 300. Make sure you get that decimal there. Okay. So that's going to give us 270. So today you can go get that item for 270 versus the original 300. Okay, make sure that you can answer questions like these. You will see them again. Now let's work a little bit the other way. After a 15% discount, an item sells for $150. What was the original price? So now we're looking for the original price. Let that be X. This is our selling. Okay, that's the sale price. So our sale price is 150, and that's going to be equal to our original minus 15% times our original. Okay, This is going to give us 150 equals 0.85x, because 1x minus 0.15x is going to give us 0.85x. If we divide both sides by 0.85, we see that x is going to be around $176.47. Okay, so the original price was around $176.47, and today with this 15% off, you get it for $150. Now, let's say that we want to find the cost or the selling price with a known markup. So now we're talking about from the business perspective, okay? Remember when we talked about markup that it could be from the cost perspective or it could be based on selling price. We definitely need to know that answer to calculate these. Just like we needed to know when we were calculating the percent markup, we need to know if we're going to apply that percent markup, right? Pay close attention to the problem it's going to tell you for this class. So our selling price is going to be the cost, so what it costs the business to buy, plus that percent markup times whatever the reference is. So whatever it says it's based on, okay? Whatever it says it's based on here. Our dollar amount of the markup is always going to be whatever the reference is here times that percent markup, okay? So you're really just adding your markup amount to the cost. It's just a matter of finding that markup amount. For example, if an item costs a business $200 and the markup is 30% based on cost, let's find the selling price. Well, the selling price is just our cost plus our markup, and we're looking for our selling price. So it costs the business $200, and our markup is 30% based on that cost. So it's 30% of that cost, so 0.3 times that cost. And that's going to give us $260. On the other hand, let's say that an item sells for $800. Okay. If the markup is 25% of the selling price, find the cost. Well, we know the selling price. It tells us right there, it's $800. We don't know the cost, okay? So that's going to be our X. And we know the markup is 25% of the selling price, so 25% of that 800. We know that our selling price, 800, equals an unknown cost plus 25% of the $800. Working algebraically, this leaves us 800 equals X plus 200. So we can algebraically solve for 600. So the cost of the item is $600. They're selling it for $800, which is a 25% markup of the $800 selling price. Now, the great thing about these is you can always check your work. Go back and plug it in. Make sure that they do actually end up equal. Okay, let's look at another example. An item is going to sell for $260. The markup is 30% of the cost. Find the cost. Well, selling price, $260. Markup is 30% of the cost, and we don't know the cost. So this is going to be 30% of X, and cost is going to be X. So we know that 260 is going to be that cost plus 30% of the cost. Again, we're going to just algebraically work this one through, and we'll find that it is $200. Okay, take a moment and pause and make sure you can get these solved on your own. I'm going to go ahead, but again, pause your video. It's extremely helpful to prepare for your test. An item costs the business $250. The markup is 30% based on cost. Find the selling price. Well, remember our selling price is going to be our cost plus our markup, which is 30% based on cost. So it's going to be 30% of our cost. And this is going to give us $325. So we'll sell it for $325. An item costs the business $500 and the markup is 25% based on selling price. and we want to find the selling price. So that's going to be our X, okay? So we know that X equals the cost plus 25% of the selling price, which we don't know is X. We know that X equals 500 plus 0.25X. Now we can subtract 0.25X from each side and get 0.75X equals 500, which divided by 0.75 is going to give us an unfortunate number of $666.67. Poorly thought through math there, huh? Okay. Let's get some more practice. Again, great place to pause. An item sells for $500. The markup is 25% of the selling price, so we want to find the cost. So we know that we're selling it for 500. We don't know the cost, 500 plus. Starting with 500, that's going to equal our cost, which we don't know. Plus our markup, which is 25% of our selling price, which we know is 500. So 500 equals X plus 125. And if we solve that, we see that X equals $375. For the next one, an item sells for $300. So we know that 300 equals something. The markup is 25% based on cost, but we do not know the cost. Okay. So it's going to be 300 equals whatever it costs plus 25% of whatever it costs. That's going to give us 300 is 1.25X. And if we divide by 1.25, we're going to see that 240 is X. So we're going to see that the item must cost $240. Okay, switching gears a little bit, but still very much related. Remember in Unit 1, we talked about a shortcut formula for finding new amounts based on those percentages, right? So our new amount could be our original amount times 1 plus or minus our change as a decimal. So, for example, if I have a 20% increase, 1 plus 20% is 1.2, and that would be what we would multiply by. We can use these if we're doing consecutive or simultaneous changes, okay? So for example, if you make $20,000 per year and you get a 2% raise, followed by a 1% raise, followed by a 5% raise, and then another 3% raise, what's your final salary? Well, here's your original. Here's your 2% increase, your 1% increase, your 5% increase, and your 3% increase, okay? 2% raise, 1% raise, 5% raise, 3% raise. We can enter this all into our calculator at once. Your new salary is now $22,283.23. Now another example. You want to buy a sofa whose original price is $1,000. Would you rather get a 20% discount followed by a 10% discount? Or would you rather get a single 30% discount? Go ahead and pause and work both of these scenarios out. In our first case, our price is going to be that $1,000, that original price. This is the 20% off. And this is the 10% off, back to back, okay? Now you're going to pay $720. In your second case, you're going to do it all 30% at once. And that's going to be $700. So which one do you want to buy? Well, you probably want to pay the least for it, right? You're going to take the second case. You'd rather get 30% off. Now, a lot of students try to wrap their head around this and make it make sense. And the easiest way that I like to explain it is to say, okay, you started with $1,000 and you took 20% off, okay? So then when you take 10% off, you're taking 10% off of a smaller number because your 10% is coming off of a number that you already took 20% from. So since you're taking it from a smaller number, it's going to have a smaller effect. Okay, go ahead and try this example also. Your original salary is $25,000 and you get a 5% raise followed by a 4% raise. So how much money are you making now? Pause if you need to. But remember that you're going to start with your 25,000. You get a 5% raise and then you get a 4% raise. If we plug this into our calculator just as it is, just be careful with your parentheses, you're going to see that you now make $27,000, well, $27,300. Okay. Now, so far we've talked about straight increase or straight decrease, but we can actually mix them. Okay, we're going to use the exact same methodology. You can mix and match these pluses and minuses, all this is saying. So let's say that you mark up a price of $200 by 15%, and then you reduce the result by 30%. So here's your original, start at 200. Here's the markup of 15%, and here's the reduction of 30%. Okay, we can do that all at once in our calculator and see that now the result is $161. You give this one a try. A merchant gives a 25% discount on an item that costs $80 and then adds 5% sales tax. So you're going to decrease it by 25%, but then you have to add 5% back. What's the resulting price? Well, your original is 80, and you're going to take that 25% away. But then, unfortunately, you must, oh, I should have written 0 there. You must add another 5%. So this is your discount, this is your tax, and if we work this out, we're going to see that it's going to be around $63. Okay, make sure you can get these. Like I said, I like these on tests. Now let's finish with one more comprehensive example here. After a 20% discount followed by a 10% discount followed by a 5% sales tax, an item costs $378. What was the original price before any discounts or the sales tax? So we know that this was the selling price. We also know that there's a 20% discount and a 10% discount and 5% sales tax. So here's our 20% discount, here's our 10% discount, here's our 5% tax. Okay. We also know that the resulting price, not the original price, was $378. We do not know the original price. That's going to be X. Okay. Multiply these three factors together to get your coefficient for X. It's going to tell you that 378 equals 0.756X. Divide both sides by 0.756, and you're going to see that X is 500. It's easy enough to check. Go plug 500 in over here where X is and make sure that it comes out to be a cost of $378. Okay. What questions do you have? This is a good place to write them down, think about them for a little while, and if you can't find an answer, reach out. Remember, you can always ask me. Always consider the Math Center. Always consider there's the Brain Fuse available to our course for free. Go to the Math Center website. And remember that there are tons and tons of practice and resources within Blackboard and your text. Okay? Use these resources. You want to get some practice. All of this comes together nicely for Unit 3. You're going to use this stuff again in the next few sections. So again, make sure you don't feel yourself slipping. You will not succeed in faking it till you make it. You won't make it. Okay? Remember to check your course schedule for your assignments. See what's due when. Assignment 6 typically covers 3.1 through 3.3, so definitely take a look. If you have any questions, I look forward to hearing from you. Otherwise, I will see you guys next time.